welcome to the Iowa Grazing Academy. These are the recordings from the 5 online sessions that were held in July of 2026. If you have any questions, please contact Shelby Gress at the email address listed on the slide. Thank you and enjoy these sessions. Hello and welcome.
All right. Thanks, Shelby, for the opportunity to join everybody today. I'm going to address meeting the animal requirements. I probably have a little bit more focus on the cow-calf operation, but I'll try to address other livestock as well. So when it comes to requirements, though, we basically have 5 basic nutrients that all species need to be concerned about: water, energy, protein, vitamins, and mineral. And I'm going to take each of these and get into a little more depth. But what determines the requirements depends on a variety of factors, including what are they weighing, or in calves, we oftentimes talk about weight. On cows, a lot of times we focus more on their body condition score because that tells us more than their actual weight does. But some measure of their body condition and size. Age has a factor, whether we're talking young growing animals or mature animals. What stage of production are they in? So are they lactating? Are they gestating in dry? Are they a growing situation? How much activity those animals have. So are they grazing very extensive pastures where there's a lot of walking to get from water source to mineral source to feedstuffs? Or are they in a smaller type paddock system like we have here in Iowa, where there's not a long distance for them to get to? And then finally, their environment. So really thinking about heat stress and cold stress, mostly heat stress from a summer standpoint. But what temperature are they in? Now, looking at each of the nutrients, water, I always list water as our most important nutrient because it's a part of about 98% of the molecules in the body and makes up over half of the mature body weight in an animal. Basically, every cell depends on water to move nutrients back and forth across cell walls. Water is needed to help regulate our body temperature, determines growth, as well as intake, affects reproduction, obviously lactation, since milk is made up of a lot of water. We need water for digestion, for lubrication of the joints, and for eyesight. So it's critical for an animal to have a steady, regular availability of water. I put down continuous here. It's something that cattle need water every day. It's not something they can get a good drink every couple of days. We want to make sure they have water daily. Usually we prefer that they have free choice access to water so that they can meet their requirements or their needs. And then we want to make sure that it's clean and safe. And I'm sure Dr. Radke is going to address this a little bit, but the quality of water is also important. And when we're talking about grazing situations, and particularly in the heat of summer, we also need to pay attention to the flow rate and refill time on our water systems. Oftentimes, livestock, cattle in particular, will go to drink as a herd. So they're all going to go together. We need to make sure we have adequate refill time on that tank so that the last cow, the most timid cow in the herd, or the most timid calves in the herd, have the ability to get a full drink of water, that they don't see the rest of the herd leaving and don't drink their fill. In terms of how much water animals need, beef cattle need about 1 to 4 gallons of water per 100 pounds of body weight. So if you think of a 1,400-pound cow, in the wintertime, she's probably down in that 14 gallons of water a day. But up in the summer, she's going to be at 50 or above. Again, we need more water to cool that body as the animals get hot. And so they're going to drink more. A target for lactating dairy cattle is about a half a gallon of water per 100 pounds per pound of milk excreted. So a 100-pound milk producing cow is going to need about 50 gallons a day. Horses, again, mature, not heavy work horses, but horses that are in pasture situations, 80 to 20 gallons a day, and sheep in that 1 to 3 gallons per day. Our second nutrient is energy. And in terms of growth and production or reproduction, I think energy probably becomes limiting in a lot of situations. Energy is needed, obviously, to fuel all our body conditions or bodily functions. Normally, our energy is provided in the form of carbohydrates, but it could also be fats. And in some cases, we can use excess protein as an energy source, although I have at a cost. It takes energy to break down that protein unit into energy units. Um, our carbohydrates, oftentimes in grazing situations, come from fiber, digestible fiber. A lot of that is then digested in the rumen or in the hindgut in the case of horses. But that's their source of producing energy. But we can also get carbohydrates from starch. When we think about corn, that's probably a starch product. Or we can get some energy from the microbes that are active in the rumen, are being passed on then into the hindgut and used as an energy source there. Our requirements are usually in pounds of energy, and depends on if you're old school like me, you learn TDN, total digestible nutrients. Since then, we've moved to the net energy system for livestock, or digestible energy in the case of horses. Our requirements are in pounds, although our measure in our feed stuff is usually percent. So intake is important. We have to pay attention to how much of that roughage or feed stuff is being consumed to see if we're meeting our energy requirements based on a poundage basis. So this is a graph that we use a lot in teaching about beef cow nutrition. It's just looking at the energy requirements of a mature beef cow from across the year, with calving sometime here in February or March. Her energy requirements on a spring calving cow are going to go up and reach its peak at peak lactation. So typically 45 to 60 days post calving, we hit that peak in energy requirements. As her lactation, milk production decreases during lactation, we see a drop off in her energy requirements. At this point where she's weaned in the fall, we see a huge drop in energy. And then as we go into late gestation, we see that increase up again into calving time. The yellow line here represents a fall calving cow. So when she's calving here in August, September, her peak nutrient requirement, energy requirement is going to hit in early fall and then start to drop off as we go through lactation. At weaning time, it's its lowest and goes up. When we think about grazing, this is important to know when we think about grazing, because when we have early grass growth, we're meeting that requirement of peak energy requirements at lactation time on a spring calving herd. On a fall calving herd, that's her lowest energy requirement. So she's able to put on a lot of body condition going into that calving time. But then we're having to provide stored feeds or look at some winter grazing opportunities to meet this peak requirement out here in the fall. Just to kind of keep a number in your head, if we look at providing somewhere between 48 and about 60% TDN or similar measures in terms of net energy, that's going to be kind of our ballpark target we want to hit in terms of meeting requirements of a beef cow. Protein would be our second limiting item or limiting feedstuff or nutrient. We get protein in two different forms on the ruminant, either ruminally degradable or RDP, rumen degradable protein, which is where we're feeding the rumen bacteria nitrogen so that they can produce more protein and more bacteria or microbes, or ruminally undegraded protein, which is where the cattle actually absorbs the amino acids in the intestines and the hind digestive system. So that's one of the challenges of protein nutrition for a ruminant animal, is we're feeding both the bacteria or the rumen microbes as well as feeding the animal itself. Proteins needed to build muscle, hair, blood cells, other kind of tissue. So our high requirements are highest in the young animal that's still laying down muscle or expanding muscle fibers, and in that gestating animal that's trying to develop the muscle fibers in the fetus, and in the lactating cow that's producing milk, which is also high in protein. I mentioned we can burn excess energy, excess protein for energy. A case of that would be where we're supplementing with like a distiller's grains or a corn gluten feed. We're overfeeding protein in those cases, but we're using the energy from that digestible fiber to help produce additional growth. Typically, and I'll show you some examples of this in a minute, most of our protein needs are met when cattle are on fresh green grass. So, immature growing grass is pretty high in protein. But as that grass gets mature or over mature, dries out, and we start to lose protein quantity, and then we become a question whether we're meeting protein needs or not. I just threw this illustration in, and I think we use this a lot. If you think about any of our forages, so this is showing grass, but you'd say the same thing with alfalfa or legumes. As the plant grows and starts to mature, our yield and dry matter increase, but at the same time, our energy value and our protein value decrease as that plant matures. So we may be able to get plenty of energy out of a very young plant, but may be lacking a little bit as we get out in mature plants. And then this is the same illustration I showed you earlier, except this is for the protein requirements of beef cows. Again, the red line is spring calving cows, the gold line is fall calving cows. Our peak requirements for protein also come in this same time as peak lactation. And our ballpark number to remember is around that 9.5 or 10 to 14% crude protein. So anything that's meeting that 10 to 14 is probably meeting or exceeding the protein requirements of a beef cow. Then our last two categories are minerals and vitamins. Minerals are needed at a much smaller level than our protein and energy are. We have two classes of minerals, macro minerals, which are our calcium, phosphorus, potassium, magnesium, sodium, and sulfur. Most of the time, we'll see those measured as a percent of the dry matter feed stuff. And then our micro minerals, those that are needed in very, very small quantities. And we often identify those as in parts per million of the product. Again, minerals are crucial in all metabolic processes, some more so than others. Some might be focused more on reproduction, others might be focused more on skin health or hoof health or breeding, those kinds of things, but they're all needed at some level. Typically, our forages alone will probably not meet the requirements for our micro minerals. They may for some of our macro minerals, but it depends on where they're at. So typically, we would suggest that we provide supplemental mineral supplementation to cows pretty much around the calendar all year round, but we may vary it a little bit based on forages. An example might be if cattle are grazing alfalfa, alfalfa tends to be higher in calcium. So we might use a higher phosphorus level to offset that calcium. When we're on alfalfa, on stored hay, we may want a little higher calcium level. But again, that varies depending on what's being fed and what the requirements are. I'm sure Dr. Rad, he's going to get into this toxicosis. For most of our minerals, there's a requirement, but there may also be an upper level that becomes toxic. And I'll just mention selenium is one that I deal with in eastern Iowa, where we want to be cautious that we don't double dip or double provide selenium, because again, it's a narrow range between requirement and toxic level. The same thing with copper. Copper is required at higher levels in cattle, but if we've got sheep out there, well, also sheep are very sensitive to copper, so we need to be aware and pay attention to that. In terms of vitamins, we divide those into water soluble or fat soluble vitamins. One of the beauties of the ruminant is that it produces its own B complex and vitamins. So we typically don't worry about having to provide B vitamins to our ruminants. It is not, B vitamins or water soluble vitamins are not stored in the body for an extended period of time. So they do need to have them available on about a daily basis. But again, the ruminant supplies most of those. So we're okay from that standpoint. Our fat soluble vitamins are A, D, E, and K. And those are vitamins that the animal can consume, store typically in the liver for a period of time, and be able to pull those reserves out. So we can build up their level of A, D, and E, and then be able to use it over time. Um, Vitamin A typically is not stored for a really high level, so we'll probably want to provide some A. Um, the fat soluble vitamins, especially A and E, um, do oxidize over time. So we want to make sure we're providing that in a mineral source that is fresh. We don't want to buy a year's worth of vitamin minerals with vitamins in it because they will deteriorate over time. So we want to keep that in mind. But the good thing is fresh green grass usually provides more than adequate levels of A, D, E, and K. We can build that up over the grazing season and at least have some carry forward of that supply in the liver as we go into winter. So I'm going to talk a little bit about the nutrient value of forages. We have a really good science base on the nutrient requirements of livestock, but in terms of the nutrient value of forages, we don't have quite as extensive of a database on that. Part of it is it's a challenge to get. So you have to be able to go out, clip, square foot or square 2 foot blocks of forages, dry them, send them off for analysis to get that database built up. So as I was looking for some options, I was a little limited, but I'll share you what I could find. So this is a study we did about 10 years ago with our cow systems project. Part of that project is we went out and we actually sampled feedstuffs and pastures. And we had 49 samples in our summer pasture grasses. I think these were taken in probably June, maybe early July. And of those 49 samples, they came back at an average of 61.9% energy and 17.5% crude protein. So if you think back to those targets I showed earlier, they are exceeding the cow's requirements on an average. But we then took those samples and we split them into the third of the samples that were lowest in nutrient value, the third that were highest in nutrient value, and then the average of all of them. And you can see these were the results from a protein and an energy standpoint. We see a big difference, and a lot of this is probably due to the maturity of the grass at the time it was harvested. Again, remembering that as a plant matures, it gets its seed head, it gets more undigestible fiber, it's lower in both protein and energy. Just to give you an idea of how that compares, here's the requirement for a late gestating cow. So this would be like our fall calvers in late gestation while they're out grazing. And you can see we're meeting the protein and energy requirements of those cows with all these levels of grasses. When we add on top of this the early lactation cows, we are meeting their protein requirements, but on those overly mature grasses, we are not meeting their protein or their energy requirements. So, ideally, or in real world, most of the time when cows are on this over mature grass, they're later in lactation, not at peak lactation. But we do have to be aware of that as we're looking at cows' needs and meeting their needs. And then here's that late lactation. So this is typically where we would be at on late summer. So think July, August, grasses, pastures. We're probably still meeting all of their requirements, both protein and energy in later lactation. But these late calving cows, we may need to be a little bit cautious of. Um, the thing I have to remind everybody of, though, is intake is important. So if we don't have adequate forage available for those cows to graze, we're going to be short on meeting their requirements. Remember how a cow grazes. She takes her tongue, which is roughly the size of your hand. She's got to wrap that tongue around grass, pull it up, and shear it off with her bottom teeth to get a mouthful to graze. When grass gets short, like less than 4 inches or in that range, she doesn't get a very big mouthful as she's trying to graze. And so that really reduces their ability to meet needs based on quantity more so than quality. Okay, here's another project that Beth and Shelby and I were all involved with. And this is one we'll feature at Kirkwood next week, is interseeding Sudan grass into pastures. So thinking about those pastures that are overgrazed, our calving pastures, ones that are sacrificed paddock areas, interseeding some Sudan grass into those pastures. We had a control where we did not do any interseeding. We interseeded either 15 pounds per acre or 35 pounds per acre. And then we went back and tested these pastures at about early August. So that was the first grazing. We interseeded in late May, early June, grazed early August, and then again probably in September. And so this is a compilation of those samplings in August and September. And I'm going to do the same thing, lay down a late gestating cow, early lactation cow, and a late lactation cow. And you can see from a protein standpoint, those pastures exceeded their requirements for protein, met their requirements for energy, except this early lactation cow. So again, we may have to pay attention to make sure we're getting enough energy in that early lactation cow, depending on the stage of growth of that grass. And then one last study I was able to find was looking at, this was actually a heifer development project, but it was looking at fescue in a drought year. So think permanent pasture, heavy fescue, southern Iowa. And they tested these samples, this pasture, about every week from when it started to green up until midsummer. And you can see the second column here is our crude protein levels. Early in the grazing season, when that grass was very young and green and growing fast, we were meeting or exceeding the crude protein requirements of a beef cow. But as we get here into late June and early July, as that grass grows down or that fescue got mature because it was not grazed off at the leafy stage, we started to lose protein and we're not meeting the requirements at that time. If we look over here at this last column of energy, again, we started out very high energy to start with, maybe didn't have enough quantity, but had high energy quality. And it declined over time as that grass plant matured. For the most part, this fescue pasture was meeting the energy requirements of the cow, provided they had adequate quantity for intake. So then one last thing on supplementation. If we do need to supplement, when? Well, whenever the intake is not meeting the cow's requirements or the forage is not growing fast enough to meet our intake requirement, we should consider some supplementation. Typically, that is when we're in drought situations and the forage is just not regrowing fast enough to meet the cow's needs. What do we supplement with? Ideally, we'd like to supplement with another fiber source because the rumen on cattle at that stage, the rumen microbes are fiber digesters. So if we can supplement with fiber, we keep the rumen happier. That's going to be hay or our non-starch carbs or our corn co-products like distillers grains, gluten, or soy hulls. Those are all digestible fiber sources of energy. And so they work really well on a grazing system. We can use our grains like corn and oats. We just have to remember we're now adding starch into that system. And we need to allow, give it some time for the rumen microbes to adjust to starch digesters in addition to fiber digesters, make that transition slowly, and probably provide that supplement every day because we don't want to with our gluten and distillers and soy hulls, we can supplement that feed stuff every other day, double the quantity and not cause problems in the rumen. But when we're using a high starch grain product as our supplement, we want to make sure we supplement daily because we don't want to be upsetting that rumen by throwing a lot of starch at it. And then how bunks on the ground, sacrifice paddocks are typically our sources. One word of advice, if you are going to feed on the ground, it's better to feed in piles versus in a long row or windrow. In this situation with piles, cows are all head in eating and will consume all the feedstuffs. When we feed in a long row or windrow, we tend to have some cows that are going to be stepping on it, defecating, urinating on it. So we have less waste and better utilization in piles. So just a quick review of a few key concepts. Forage availability and intake is really important when we're on pasture. The quality nutrient analysis of our grasses and our pastures are typically very good as long as that plant is green and immature and growing, but we need to make sure we have adequate quantity. Remember that as a plant matures, quality decreases over time. And so the more mature that plant is, the less nutrient available to the animal. Weather is a big factor in our pasture grass growth, as well as nutrient analysis and availability from an intake standpoint. And finally, you need to learn, or we need to all learn to read the grass or the pasture in terms of determining when we need to supplement. So when growth is not meeting intake requirements, that's the time to consider supplementing. Again, here's my contact information, and if you have any questions, or if you go to the iowabeefcenter.org and look for our forages page, we have a lot of resources there. So